Looking at number 2 from worksheet 1, particle motion. Alright, so we have a position. T is measured in seconds, x is in meters. Find the velocity at time t and at t equals 2 seconds. Well, we know velocity is the derivative of the position. So, lovely. We've got to do a quotient rule for this one to take that derivative. So f prime is equal to 1. G prime would be 2t. So this isn't a terrible quotient rule. We do got to remember the rule, though. Let's see. It's gf prime minus fg prime over g squared. That's the quotient rule. So gf prime 1 plus t squared minus fg prime, so that would be minus 2t squared over g squared. Clean that up a little bit. Negative t squared plus 1 over 1 plus t squared squared. And then, so that's part of the answer. That's the velocity at time t. The velocity at time 2 means just plug 2 in. For t. And you may remember that's a safe stop. I could leave that right there and be okay. Negative 3, but I don't know. I'd like to know what the velocity is other than just some expression with squareds in it. So I'm going to keep going. Negative 4 plus 1 is negative 3. 1 plus 4 is 5, and then square that, we get 25. All right, part B. When is the particle at rest? When is it moving to the right? When is it moving to the left? So rest would mean where is v equal to 0? So 0 equals negative t squared plus 1 over 1 plus t squared squared. The only thing that makes a fraction 0, though, is if the top is 0. So I'm really only concerned about the top. So negative t squared plus 1 equals 0. So t squared equals 1. Oh, here's the plus or minus thing that we need to be careful about, or not careful about, as long as we only get a positive one, because it said earlier that t had to be greater than 0, so we're not concerned about negative times. So at t equals 1, the particle is at rest. But it wanted to also know when is it moving to the left and to the right. So I'm going to do a velocity number line for intervals to figure out. And we've done this before with the first derivative test. Where is it increasing? Where is it decreasing? Where is velocity positive? Where is it negative? And that'll tell me where I'm moving to the right or to the left. So I can test 0 and I could test 2. V of 0, zoom out, look back at my velocity equation. If I plug in 0, I get 1 over 1. I get positive. If I plug in 2, we already plugged in 2, right? A lot of times the test and AP test will kind of rig problems to help you find stuff that you need later on. V of 2 is negative. So that means from 0 to 1, we are moving to the right. And from 1 to infinity, we're moving to the left. That will probably also help when we do a motion diagram. So we'll move to the right and then we'll go left. Part C, find the displacement of the particle during the interval 0 to 4. Right, displacement. So that's just where we are minus where we started. So s of 4 minus s of 0. Oh, I guess this one's in x's, but so x of 4 minus x of 0. So x of 4, so I look all the way back up at the position equation. So when x is 4, we're at 4/17. When x is 0, we're at 0. So the displacement is 4/17. Or 4/17 to the right of where we started. I don't really know how we got there, how much back and forth went on. We may have traveled more than 4/17, but 4/17 is the displacement. I'm guessing, yep, part D, find the total distance traveled. Well, it doesn't ask for one, but I'm going to do a motion diagram because that will help me with total distance. So a motion diagram is the number line that's the position number line, the position graph. And I need to know where we start. And I need to check any critical points. So we already found that. It was 0, or the velocity was 0 when time was 1. And then, let's see, it wanted between 0 and 4. So 4 is my other endpoint. And we have that one. It was 4/17. So when t equals 0, we're at x equals 0. That's not always the case, so be careful about that. I think we'll do one later where it's not the case. So we'll see that. It's not always the case, so just be careful. I know that I move right for a second, so at t equals 1, I should be over here somewhere. And then I guess I move back to the left to 4/17, but I need x of 1 to figure out where we are. So all the way back to the beginning for the position equation. So when time is 1, we're at x equals 1/2. Okay, that matches what we said about velocity. We move to the right for the first second. And then from there on, we're supposed to be moving to the left the rest of the way. So I could just draw the arrow because we're headed left the rest of the way. But at t equals 4, that's the one we're concerned about. We're at 4/17. 4/17. That's close to a fourth. I mean, close enough for a picture anyway. So somewhere right around there. T equals 4. So total distance would be, we need to figure out how far we went from 0 to 1. Well, that's an easy one. And we need to know how far we went from 1 to 4. That one's a little bit harder, but it's 1/2 minus 4/17. And so our total distance is the two put together, and I'm definitely going to use a safe stop on that. I don't want to risk messing up fractions when I don't have to. Just leave that alone and be good. If you want to mess with it, I guess you could. I don't guess it would be too bad. 1/2 plus 1/2 would be 1. Minus 4/17 would be 13/17. But I would not do that. I would leave the safe stop. Plus, the safe stop is kind of helpful because it helps you see that you traveled 1/2 for the first 1 second, and then over the next 3 seconds, you made it that far. All right, motion diagram didn't ask for it, but the test will, so that's why I wanted to go ahead and do one of those. And again, the color coding maybe helps see where the pieces are. Part E, find the acceleration of the particle at time t and at t equals 3 seconds. Acceleration is the derivative of velocity. So I've got to go, let's see, just flip the page over and start fresh here. Velocity was negative t squared plus 1 over 1 plus t squared squared. So this is going to be a bit of a pain. Whoops. Because I don't think there's any algebra I can do first to make this a little easier. Like, this is just, I don't even think I want to square that out in the bottom. So quotient rule. Derivative of the top, negative 2t, that's not too bad. Derivative of the bottom, let's see, so we got power rule, so 2 times whatever's in there to the first, chain rule times 2t. And then we got to put it all together. gf prime minus fg prime all over g squared. gf prime this is definitely going to be a safe stop problem, minus fg prime 2t times 2 times 1 plus t squared times negative t squared plus 1. I think that's right. Fg prime, because there's f, and all of that is g prime. I guess I could have wrote that as 4t, but whatever. And then the square of the bottom, so that would be 1 plus t squared to the 4th. Is there some algebra simplification that we could do? Sure. Is there some algebra simplification that I don't want to do? Absolutely. So I will leave that as my answer. And then it wanted the acceleration at 3 seconds. Again, maybe cleaning that up makes it easier to plug in 3, but I don't even know that that's the case. I'm just going to plug in 3 where it is, or as it is. In fact, I'm going to, well, it's not abusing the safe stop, it's using it to your advantage. Again, does that simplify to something easier? I don't know, maybe. We could do more, but why bother? Let's don't worry about messing stuff up when we don't have to. Maybe it simplifies to something easy, but since we don't have to use it later, I'm not worried about it. Let's leave it alone. Part F, speeding up and slowing down. So for that one, we would do a velocity number line, which we already have. Right, because to the left of one it was positive, and to the right of one it was negative. We would also need a acceleration number line, which for our purposes I'm going to say no thanks, because that looks terrible. The one on the test is not nearly that bad, because you would have to set this thing equal to 0 to figure out where the velocity was 0, or where the acceleration was 0. And yeah, I don't want to do that. I don't want to mess with it. Because not only would you have to find where it's 0, then you'd have to test either side. Although I was going to say we tested 3, but not really. I don't know if that's negative or positive looking at that thing. Yeah. So we'll do that on another one that's not nearly as difficult. But just to review, speeding up means velocity and acceleration have the same sign. Slowing down means they have different signs. They're sort of fighting each other, so you're slowing down.